Our today's topic is combination of registers. We will study today combination of registers in this video. The question arises that why we combine the registers. First answer may be our curiosity, and the second may be our requirement. Sometimes we want to know if we combine two registers, what will be the equivalent registers, and other time we may consider that we may require that a particular register by combining two registers. There are two ways in which we connect the registers, we combine the registers, and the first one is the register in series. In this combination, we connect the registers end to end like this, and same current flow through both the registers. So you can say when two or more registers are connected end to end in such a way that same current flow through both the registers, then they are said to be connected in series combination. A simple case is a string of bulbs which are used to decorate our houses during Diwali. Here each bulb act as a register. We will now study simple cases of registers either connected in series or in parallel or a combination of these. Here I have taken three registers connected in series. This R1, this R2, this R3, and voltage V is applied. When current flow through a resistor, a potential drop occurs across the resistors. This potential difference can be found out by Ohm's law. Means the potential drop across resistor R1 is V1 equal to IR1. Here if I want to calculate how much potential drop occurred over here, this can be calculated by using this formula V equal to IR. Here voltage is V1 across resistor R1, and current I is flowing through R1 as well as R2 and R3. Therefore I have written here V1 is equal to IR1. In the same way voltage drop occur, R2 is equal to V2 is equal to IR2, and in the same way voltage drop here through R3 is V3 equal to IR3. In this way, voltage is, you can say, the voltage, whole voltage V is divided across the resistors, and here V1, V2 and V3, and the values of V and V1, V2 and V3 placed here in this equation, and here I taken common. If Rs is the whole resistance of the circuit, and through whole resistor current I1 is flowing, so voltage across the circuit is V, and we can write V equal to IRS. Definitely this IRS will be equal to the this value, and I will be cancelled, and you will reach to this result. In this way, in series combination, we simply do the algebraic sum of the individual resistors. Now we will discuss parallel combination. Here the parallel combination I have taken, the resistors are connected in such a way. Here three resistors R1, three resistors R1, R2, R3 are connected in such a way that current flowing in the circuit is divided at this point A. Some current flowing in this direction, some current in this direction, some current in this direction. That means current is divided, and in the series case the voltage was divided across the resistors, and here current is divided through the resistors. Simply I can say that total current in the circuit, suppose I, total current in the circuit, suppose I, and this current I divided in three part, I1, I2 and I3. It means I can write I is equal to I1 plus I2 plus I3. This is written over here. Current I current I is equal to I1 plus I2 plus I3, and applying Ohm's law over here, in place of I can write I equal to V by R. You know it by Ohm's law. Therefore, in place of I1, I have written here V divided by R1. In place of I2, V divided by R2. In place of I3, V divided by R3. Okay, in this way we got this value, and this this V has been taken common, and here again Rp is the total resistance. Rp is the total resistance. This Rp total resistance of the circuit. So we can say that total current I is equal to total voltage divided by total resistance in parallel. Therefore this will be equal to this one. Here V cancel, ultimately you will get this relation. Then parallel combination, we connect the resistors in this way. This is the formula to calculate. Here one thing important to discuss, when two resistors are connected in parallel, then this formula can be applied. 1 upon Rp is equal to P for parallel, 1 upon R1 plus 1 upon R2. And this can be written like this: R1 R2 LCM, R1 and R2, and this will be equal to 1 upon Rp, and here you will get R1 plus R2. And this I have solved from here, this I have solved. Okay, and when you take the inverse of this one, you will get this. R1 R2 will become the numerator, and R1 plus R2 will be denominator, and 1 upon Rp will become simply Rp. In this way you can directly apply this formula if there are two resistors connected in parallel. I explained this in this video how to connect the resistors in series and parallel, and what are the formula to calculate their equivalent resistance. So this video is going to end now, and in next video I will explain you heating effect of electric current. See you in the next video.